Lara. Today I will talk about how to tag desktop applications use web security skills. This may sound weird, but after this talk, you can see how we can pop up a calculator without reversing or binary exploiting knowledge. I'm Sot. I'm from Tencent's Security Junyu Lab, and I'm a member of OOPS, the CDF team. And I have spoken at Zero Nights and Hit B. And my friend Heeman, he also from Junyu Lab, and he is a speaker of Asia SecWest. And another friend, he's from Tencent Junyu Lab too. He's a member of C-Clover security team, and he's spoken at Zero Nights and Hit B too. Unfortunately, these two guys doesn't come here. Okay. When people are talking about attacking desktop applications, you may think about Web2Own. Yeah, hackers at Web2Own may use memory corruption bugs to get a calculator. I dream of that one day I can pop up calculators just like them. But there's some difference between me and them. I just know something about web security. I can do little reversing. I know nothing about pawning. Can I pop up a calculator like people in the Web2Own? That sounds a good question. Yeah. And we notice more and more applications use hybrid technologies. People write applications use frameworks like Electron or NW.js. So their applications can run at all the platforms. And web techniques are used in these frameworks, and they may use web techniques to develop their applications. So that's a good news for our web security researchers. Yeah, we can use web security tricks to pawn them reliably. Let's see how to pop up a calculator, use web security knowledge. Let's keep web security great. So let's start off from the attack surfaces. So today in this talk, we will talk about 3 sections. One is open pause. The second one is URL schemes. And the third one is some features of the applications. Yeah. So we start from when the application opens a port. So why do they open a port? Maybe they open a port for the web server because they want to expose some API calls. And maybe they use the port for debugging and many other purposes. And the application may bind the port on all the interfaces or on the local host. Yeah, on all the interfaces you can access them remotely, but how do we access the ports on localhost? And the browser is our good friend. If the service running on the port accepts HTTP protocol, or it has a tolerance of illegal commands, and then we can use browser to attack these localhost ports. And before we come to the exploiting, let's see some basics. The same origin policy. Yeah. We see that 2 pages have the same protocol, host, and port, and these 2 pages are in the same origin. So for pages in the same origin, they can send simple HTTP requests or send requests with custom headers and get the response. If they are not in the same origin, they can only send the HTTP requests and cannot get the response. So how this basic restriction in the browsers, is there a way to bypass this? There comes DNS rebinding. So the process is as follows. We first access the rebind.com. It will resolve to an attacker's IP and pull all the payloads from the attacker server. And in the browser, you just wait with a few with a few minutes, and you request rebind.com again, and then this domain will result to the target IP, such as localhost. And the port, the protocol, and the host are not changed in this process. So the browser believes they are in the same origin. So we can attack it, just bypass the SOP. Yeah. So we need there are some prerequisites. The web service should not check the host name, because we need a domain name that we control. And the victim should wait until the DNS has changed, because there is a cache in the browser. And there is another attack method called CSRF. And there's some difference about CSRF and DNS rebinding. We can use DNS rebinding to bypass SOP, but if there is a hostname check, it will fail. And if the client cannot wait a few seconds, and this may be not work. But for CSRF, it is restricted by SOP, but it doesn't. The host check doesn't matter, and it will be effective immediately. Yeah. So let's just go to a case. And it is a popular third-party plugin for WeChat. It is a popular chat software in China. Yeah. And it is called this WeChat plugin, macOS. Using this third-party plugin, we can keep the record message. We can auto-reply a message. And it has many users. You see many stars and many folks, but it just stopped maintained months ago. And it binds a port, a fixed port, on localhost and expose some APIs. From these APIs, you can get all the users' friends, all the chat logs, and you can send any message to any user. And we can use DNS rebinding to attack this plugin. So we reported this issue to the author, and the author fixed with checking the host. Yeah, the host cannot be a local host. Because of this host check, we cannot use DNS rebinding to attack them, but it is still affected by a CSRF attack. If we know a username, we can then use CSRF to send a message to that user. Yeah. So it is not enough to just check the host. Because check the host, it can just keep DNS rebinding away. You should also use some unpredictable data or path to prevent CSRF attack. Also, most importantly, you should avoid using third-party plugins. And there's another case called XDebug. XDebug is for PHP debugging. It's a PHP extension. So how does it work? First, you should send a request with this in parameters XDebug session start, just like that URL in the URL below. And then the XDebug will connect to a server, and the server can interact with the XDebug. So which server to connect? XDebug will check the following things in a fallback order. The first one, in the XDebug's configuration file, the XDebug remote host. If not set, then it will check X40.4 header in the HTTP request. And if not, Xdebug will use remote address. So if we have these three configurations in the Xdebug remote connect back set to true, Xdebug remote enable set to true, and the remote host is not set. And this is always met for most of the PHP developers. Then we can attack it using DNS rebind. We can set up a EVL server waiting for Xdebug to connect, and then use DNS rebinding to send a custom X40 for header and points to the EVL server. So the EVL server will interact with the Xdebug, and finally we can get a reverse shell. And I have reported this to the PHP. So if you are a PHP developer, if you use Xdebug and you stay on a EVL page for 40 or 50 seconds, and then you may be hacked. So how do the Xdebug officially think about this attack? And its response with, it thinks this is just a rumor. And for developers, himself should take care of this. Yeah. So anyway. And for Node.js debugging port or Java debugging port or Java RMI port, they may also be affected by DNS rebinding attack or setup attack. So if you find a port opened by an application, you can check it based on all interfaces or based on localhost. So you can choose to attack them remotely or using DNS rebinding or set up effort to attack them. And next part, UI schemes. This is a short part. Yeah. People use URL schemes to launch applications or send some messages inside an application. We can see the following picture. We can use React Code URL schemes to launch React Code. Yes. And on in Windows, it is registered in the registry and has an item for the UI protocol name and the command it will execute. Windows will use shell execute W, this API, to call that command, to call the React Code command and launch it. But there is a well-known bug in this API. We can use a code to close the former code, and we can inject other parameters. So there comes a famous exploit last year for Electron. We can use a Chromium parameter injection and to execute any command, just like that. And we found all frameworks based on Chromium may have the same issue. So the nw.js framework, we found a famous application for note-taking use nw.js, and it has 200 million of users. So we can just inject Chromium parameters to execute any command, just like the Electron bug. So here comes the demo. Yeah. We set our web server on the local host, and this is explore page. Yeah. If we clicked that, we will get a calculator. Okay, this is the first calculator. And this bug is fixed, already fixed. Yeah. And in this May, Microsoft released a patch called KB 4497935. If you applied this patch, you will find the UI scheme is now URL encoded. So in this case, we cannot inject parameters because the code are URL encoded. We cannot close the formal code. Maybe URL scheme is that, or there is some bypass. Who knows? Yeah. So if you want to find URL scheme bugs, you should check the URL schemes that the application has. Also, the framework has. Don't forget the framework. Yes. And the main part, we attack the features of the application. And this section, we have 3 parts. First one is cross-site scripting in the desktop applications. The second section is for privileged APIs. And the last one is for improper protocol handler. And the cross-site scripting story begins from Markdown editors. And in the year 2016, we found many Markdown editors just renders the JavaScript in the preview window, such as MOU, Markdown, or even wet code. So many of the Markdown editors just previews the page in a file domain. So we can use the JavaScript executes on the file domain to steal files on the local disk. And we can steal some credentials from the local host, and we may clone his account and log in another machine. And also, if it has some privileged APIs, or it uses outdated browsers, we maybe get remote code execution. Yeah, let's see a case for Markdown. It has thousands of stars and manifolds. And this is also this exploit can also be used in the latest version. So we can see the location is in a file domain, and we can use XML HTTP request to get the etc password. And we can also send that the response that the content of the etc password to the remote server, so we can steal local files. Yeah, I reported this in the year 2016, and it is still not fixed. But things are always getting harder. There's little cross-site scripting in Markdown editors nowadays. And some editors use content security policy to limit JavaScript execution. And some editors use sandbox to run the JavaScript in a isolated context, and they're without node modules. So the issues are harder to find and harder to exploit. But we should think about the libraries that used by Markdown editors. The first one, Mermaid. It is used for charts or diagrams. On the GitHub, it has thousands of used products and many stars and many folks. We have found 3 cross-site scriptings. In the latest version, when I make these slides, but now in the latest version, it has fixed. Okay, latest version here is when I make these slides. It is fixed days ago, just days ago. Yeah, we can say the Typer, the HackMD, the Evernote, and GitLab use Mermaid. And there is the cross-site scripting. And the first two just renders the HTML. And the last one need a click. It is click cross-site scripting. And here's demo page, the official demo page. We can alert. And next to context and magics, these two libraries for math typesetting. And in their old versions, it has a click cross-site scripting too. And this too is reported by other guys. Okay. And the last library, flowcharts.js, it has a click cross-site scripting too. In the latest version, this has not fixed yet. So if you use Mermaid, please upgrade it to the latest version. Yeah. And the older version of MathJax and Codex has cross-site scripting issues, and the latest version of flowchart has a click cross-site scripting. As these issues lies in the libraries, so these issues may affect more applications than we can find. So here comes the keys for HackMD. It uses Mermaid. It is an online Markdown editor, and it has many users. We just used the payload before for Mermaid, but the payload is blocked by CSP. Yeah, we cannot see the alert box here because the CSP just blocks it. And then we checked the CSP. We found an interesting site there, the Google Analytics. There is no way for using Google Analytics to bypass CSP by Kitten. Yeah. So we can use Google Tag Manager and set a variable there and set a malicious function. We can define a malicious code there. And the code will be shown in the Google Analytics. And you can check the details in the following link. So then we can get an alert box. Yeah. And we found there is also a desktop application for HackMD. There are two elements. One is a script element for render.js executes in a privileged context. And a web view tag renders the user page. There is no node integration. So how to turn our cross-site scripting in the web view tag to RCE in the desktop application? So let's check the render.js first. We can see from the code, it adds an event listener for DOM ready. And when DOM ready, it will get the title from the web view and set it to the inner HTML, to the privileged context. So if we can control the title, we can execute any JavaScript code in a privileged context. So we can use our cross-site scripting to redirect the page to our evil page, which can trigger the DOM ready event. And then our page have a special header, a special title. And we can use this to call the node modules process and the child process and execute any command. And then we can see the calculator. Just click the malicious markdown and pops up the calculator. Okay, I have reported this to the HackMD, and it has already fixed. So there's in some cases, we may not execute JavaScript we can only inject some HTML code. So we can also use this, use HTML code for phishing or just advertising. Yeah. Anyway. So the next section, the next part for privileged APIs. Privileged APIs comes from about two ways. One is the node modules, another maybe some from the custom APIs. The program just added these APIs. Programs usually use a JS bridge with some wrapper to provide custom APIs, and these usually has a public documentations. So let's see a case. It is a case for a popular chat application. It has billions of users. In this application, it has an embedded browser with some custom APIs. So if you render your page on the embedded browser, you can call the custom APIs because there is no domain restriction. And these APIs are well documented for developers. And how to open URLs in the embedded browsers? There are two ways. One is in the special type message, which is called feed card message, just like that. And also, we can use an inner app application URL scheme. We can use a special scheme to open the embedded browser. And in the custom APIs, there's two interesting APIs. One is download file. If you call this API, you can pass a URL to it, and it will download a file from that URL. But it will pop up a box for the user to choose the location to save that file. Yeah, this needs some user interactions. And another API called open local file. It just opens the file you just downloaded without confirmation. Yeah, this API is without user interaction, but only works on macOS. So we can make it download ELF to execute, but failed because it has no X mode after downloaded. Yeah, we think we can use a Bash or Python script, but it is usually opened by a text editor. So how to exploit this? Java is a good friend. Yeah, we can just make it download a jar file and use that API. Just open the jar. It will execute all Java code. So if you have Java and you click a feed card message from a hacker, and a dialog will ask you to save a file. Save a file usually harmless, so you click save, and then you are hacked. So let's see the demo. Yeah, maybe some conversations for social engineering. And come the feed card message. Just click it in the embedded. You should click save, and then the calculator. And this is already fixed in the latest version. Yeah, and it is fixed by just open the folder instead of the file. Yeah. And the last part. Let's go to the part for protocol handler. When developing desktop applications, you should pay attention to these three protocols: HTTP, JavaScript, or file protocol. For HTTP protocol, you should avoid you render pages in an untrusted context, because if you have an outdated browser core, you may be affected by the browser one day. Or if you execute JavaScript, the JavaScript may exist in a file domain. You can steal files. And for the file protocol, you can use it to launch programs in your computer. Or the file protocol may leak NTLM credentials. So just be careful of A tag. So we find a library, and it is used in Chinese applications, and it is widely used. It has many stars and many folks. And it supports HTML-like tags if you set show HTML to true. And there are some tags such as A tag for hyperlink, an I tag for an image, and a C tag for a text color, change the text color. And in a chat application, it says show HTML to true. And it renders the tags in the chat group name or your personal status. We can use C tag here to change the text colors. Yeah, we change it to the red. And change the color may be harmful. We can use I tag to do some NTLM relay attacks. So we can use I tag to insert a file protocol, SMB protocol. And it will, in Windows, it will send the Windows credentials automatically once the tags are rendered. And these tags are in the status, personal status, or on a group name. So usually this can be done without user interaction. And the attacker can get the credentials. They can just do some offline brute force works. Or the attacker can relay the credentials to other services, such as to the Exchange server. So we can log into the Exchange server on behalf of the victim and get all the emails. Or if the victim have another machine share the same password, we can relay to that machine and get remote code execution. And there is another case for Ghidra. And Ghidra is developed based on Java. And it uses XML to describe a project. So there is a XSCE in the Ghidra project description file. It is found by this guy. Yeah, we can use XSCE to steal files or use XSCE to send HTTP request. But can we turn the XSCE to RCE? Based on our previous research, this can be done. We found that Java will send credentials when it encounters a NTLM-based 401 HTTP response, not the basic authentication. It is NTLM-based 401 HTTP response. Yeah. The attacker can set up a malicious HTTP server to respond that, and the Java will send the credentials to the attacker, and the attacker can just reflect the credentials to the C machine, just the C machine. So if you just opens a malicious project and you have opened your SMB service, and then you may be hacked. So here's demo. We set up a malicious server, and here is our Ghidra. And it will open the malicious project. And then the XSCE triggers. We can dump the hashes. Just get the hashes of that machine. And then we can use pass the hash to execute any commands on the victim. We just use that hash. And there's a mistake. There's a mistake. And we fix the command. Yeah, we can see the calculator. Yeah. So there's many features in desktop applications. So we can find cross-site scripting, and we can find if there are some privileged APIs. We can find how it handles the protocol. We can find that and check how we can attack these applications. So here's come to the end. If you are a developer, just be careful while debugging PHP, Node.js, or some older version of Java. You may be popped up a calculator on your desktop. And also, you are a developer, you should be careful while using these libraries. Some older version of Mermaid and older version of MathJax, Ktax, and the latest version of flowcharts. And if you use dual-lib, you should not set the show HTML to true. And if you use nw.js, be careful while registering a URL scheme. And thanks for this, guys. And thank you all. Thank you. So maybe any questions? Oh, yeah. Okay, thank you, guys.